library and do it. So you have to have a proctor. Can't take it at home unless somebody comes to your house. Yeah, all right. Thanks, Luna. You're done. Okay. Hi, Harley. Good to see you. Yep. State tests have to be done. The state doesn't trust us, I'm sorry to say. You can't do it from home. You got to have a proctor. Yep. So if you haven't done your math test today, you remember that if you have math in the afternoon, you have to go to your math course card at 12:50, right? So you haven't done that yet, make sure you do it. All right. So I imagine that some of you guys, one of the reason that we're kind of light on people being here is because people are testing. So let's do this assignment here. This is our quizzes to review what you know about the Newton's first law, what we talked about yesterday. So we got to kind of drill that into your heads, right? Drill it, drill it, drill it. So here we go. Let me clear this chat out for a second. All right. All right, so if you guys will get in there and let's do some Newton's first law review. 10 questions about Newton's first law. Hey, Hayden, good to see you. Hey, Lucas, good to see you as well. Thanks, Luna. Thanks, Cadence. Thanks, Adriana. Good to see you guys. Hey, Bari. All right, anybody else in there? Because I'm doing, if you'll see this, I'm going to edit the PS5 assignment here, and I'm going to put some new names in here. Okay, so I'm going to edit it. So people that are participating are going to get in their names. So I already got Cadence and Jaina. So I can put more people in there. Going to have a drawing at the end of the hour. So I put people in. So I don't have, who else do I have in there? So I just have to do this as my wheel of science. That's what Luna said. I'm going to call it the wheel of science. All right. So we got Steven. All right. Natalia, Bari, Luna. Thank you guys. Let's get started on this. All right. All right. So what's the first law also known as the law of inertia, right? Law of inertia is what this law is all about. The resistance to movement, right? Hey, Tiara, good to see you. Get into this assignment here. All right, we're having the wheel of science today. All right, Janelle is here. Luna, remember it's inertia. You guys can't get that in there. Get inertia. It says inertia. Somebody put gravity. Inertia is what you're looking for. Resistance to motion. Could be that you guys got laggy computers. You're not in there. Janelle, you says you're in. All right. Who else? I still waiting for you, Janelle. What's going on? You says you're in there. Oh, we got I don't know who this Plexus back is. Who's that? Anybody tell me who that is? All right. Okay, so this is next question here, Jana. It's not wanting to work. Okay, question number two. Question number two. All right, what kind of objects have inertia? If you said objects with mass, you are correct. Objects with mass have inertia. Hey, Greg, good to see you. James, good to see you. You guys want to jump into this quizzes here? We're having a drawing for some more free science giveaways. I don't know what I'm talking about. Steven's there. Thanks, Madison. Janelle, you're still having trouble today. It's not letting you go. All right. So next question. An object in motion will stay in what kind of motion as long as the net force is acting on it are zero. All right, so this one is constant motion in a straight line. Straight line. So you shoot something into space, it will continue going in a straight line unless something else acts on it. So there are gravitational forces that pull it. So as well. How did we do, guys? Still waiting for Luna. And we got more people. We got Greg. Oh, Jana, you came in twice. All right. All right. There we go. Got everybody. All right. So full-time view. What is Newton's first law? An object at rest stays at rest. An object in motion stays in motion. All because of inertia, right? All because of inertia. All right. Just waiting for Adriana. All right. So we're looking for objects at rest, stay at rest. Objects in motion, stay at motion. We got everybody. Excellent. The best class ever. You guys are so great. Next question, 5 out of 10. All right. Oh, look at that. Everybody's got 2,400. Woohoo. So after a cannonball is fired into a frictionless space, the amount of force needed to keep it going equals 0. No force is needed. It keeps moving in a straight line until it gets hit by an unbalanced force. So you don't need to do that. So that is the cool thing. That's why we want to have moon bases. We can shoot those puppies off of the moon and get them going when we build them there. So you guys are going to be able to do that because I'm not going to be able to. I'm going to be too out of shape and too old. Come on, Steven. Come on, Madison. Going on forever. All right. Looks like laggy computers. Oh, there's one. Oh, right. Everybody's got it. Excellent. Right. An object that has twice as much mass as another object. The first object also has twice as much what? Inertia, right? Inertia, because it all depends on your mass. If you're as big as a planet, boy, you would have so much inertia, it would be very hard to move. That's why if you jump up and down on the Earth has so much inertia, you don't feel it bounce. You don't feel it move. It moves a tiny bit, but not much. We'd all have to be bouncing up and down to get that. So inertia is what we're looking for. They would have double the inertia, right? Double the inertia, right? How about you, Stephen? Almost there? All right. Okay. Nope. Can't get it. All right. Number 7. All right. Resistance to change in motion is inertia. So we can call inertia just about anything, right? Except for late for dinner, right? Inertia is inertia is inertia. Still waiting for Madison. How about it, Madison? You got inertia in there? 7. There we go. Excellent. All right. So inertia object depends only on its mass. Gosh, I think we've talked about this question before. Only depends on mass, right? Only depends on mass. Only depends on mass. Yep. So how much material is in the substance, right? How about you, Stephen? You almost there? What did we get? New person. Rosa, good to see you. All right. does not cause change in motion. Balanced forces do not cause change in motion. Unbalanced forces cause acceleration, right? Balance does not change the motion. Two more people. Adriana, balanced, and Stephen, balanced. The word is balanced in French. Oh, you clicked on the wrong one. Not a problem. All right, number 10, last question in this. All right. The rock sitting on the ground is balanced, right? Because it's not moving. Unbalanced forces cause us to accelerate, right? Unbalanced forces cause us to accelerate. Adriana, you still with us? One last person. Ready? Uh-oh. Cannot, come on, Adriana, put balance down. Balanced. Maybe she's walked away. Nope, she's still there. All right. And the question and the session done. Let us see who the winners are. Okay. We got, I don't know who that playback. Who's that? Who is that person? So I give them some credit. Who is that? Harley. Thanks, Harley. Good job, Harley. Anybody know? Nope. Okay. Good job, guys. Okay. All right. So I'm going to add some names to people today because this is a tough assignment today. I hate to say this, but there is some math. But you know what? How many people in the chat here? Let me see. How many people are good at dividing, multiplying and dividing? Okay, let me ask that question. Good at multiplying and dividing. Good at multiply. So I'm going to put X. I'm going to put multiply, M-U-L, M-U-L, and D-I-V. A, yes. And B, now that I'm talking about using a calculator, okay? B, no. B, no. So it's not going to hurt you if you tell me the truth here. So, and nobody else will know besides you or me. All right. So what is it? Multiplying, dividing with a calculator. Are you a yes or a no? I got 3, 4, 5, 6, 7, 8, 8, 9, 8 people. I got 7 said they're good. All right. And I think one person just doesn't like math, but that's not a problem because it's just multiplying, multiplying and dividing. All right. So today we're going to do that drawing today. So you put your name in the spinner here. I'm going to type the names in the spinner for those people that played in the quizzes. All right. And I'm going to type the names of people that participate in this too as well. So I got 9. I had more in that other one. So great job, ladies and gentlemen. All right. So let's take a look at, so we're going to have some more poll questions. So if you haven't got a chance to get into our poll yet, we've got about 14 people in the poll out of 18. Fantastic, guys. You are doing so great. So we're going to watch about 2 minutes of a video, 1 minute, and ask some questions. So let's do that. So let me give this a shot for you guys so you can see this, so I can hear this. So we're going to talk to Professor Dave. Professor Dave. I love Professor Dave. He's almost as good as Bill Nye the Science Guy. Not as good, but Bill Nye had more energy, I think. Okay, so let's take a look at this first one here. So we're going to use formulas. We always use formulas, right? Formula, like baby formula. It's really simple. Like baby formula, it's really simple. Calculate the relationship between force, mass, and acceleration. So it's something that's pretty straightforward. So Professor Dave, tell us what's going to happen here.
Professor Dave again. I want to tell you about Newton's
Can you guys hear that okay? Are you able to hear Professor Dave? Yes, no, maybe so. All right. Thanks, Luna. Let me turn my camera off so you guys can see more of Professor Dave.
Second law.
He knows a lot about the science stuff. Professor Dave explains.
We learned about Newton's first law of motion, which tells us that an object will continue its state of motion unless acted upon by some net force. The second law continues from there, describing what will happen if some net force is indeed present, whether from internal or external forces. This law tells us that force is equal to mass times acceleration. This is summarized in the following equation, F equals ma. What it means is that we can do quantitative calculations relating the magnitude of a force applied to an object, the mass of the object, and the magnitude of the acceleration that object will experience.
Okay, so again, we're moving on from Newton's first law, and now we're adding net forces, so unbalanced forces. And let's do this. All right, so let's do a poll question for you guys. All right, so of these, which, according to Newton's law of motion, second law of motion, A, mass times density, B, mass plus acceleration, C, mass times acceleration, or D, mass divided by acceleration? Remember, you guys we're going to have a wheel of science going on at the end of the hour. So the more people that get in, more chance that you have to get into a freebie assignment. 15 points is yours. And we've got 3, 6, 7, 8 people. Thanks so much. Some people, come on, Adriana, AJ, Candace, Caden, sorry, Colt, Greg, Hayden, Jabari. Come on, you guys could be lucky today. You could be really lucky. All right, I guess not. 10 out of 20. Oh my gosh, 11. And most of you guys got it. It's mass times acceleration. You guys are great. Mass times acceleration. So let's see if you remember what the formula looks like. Which is it? Is it F equals ma, F equals 2ma, F equals m slash a, or divide by a, or F equals m plus a? Holy cow, everybody's all over the place. So what is the mathematical one? And guys got to pay more attention. Oh my gosh. It is the first one. Force equals mass times acceleration. Force equals mass times acceleration. So straightforward. The M and the A means you multiply, right? M and A means you multiply. All right, so make sure that you're paying attention here. All right, so let's take a look at the video again, and we're gonna ask 2 more questions of you guys, no more than 2 more, and then we're gonna do some problems. Okay, so let me get to sharing with you. Share the video and make them big. Come on, Professor Dave, tell us the rest of the story. All right, Professor Dave,
And it shows the derivation of the Newton as the SI unit of force when we plug in 1 kilogram and 1 meter per second squared for mass and acceleration. There are a number of things we can say about this equation, which is tiny but powerful. First, it means that heavier objects will require the application of greater force in order to achieve the same acceleration as lighter objects, with acceleration being equal to force divided by mass. If we want these objects of varying masses each to accelerate at 1 meter per second squared, these are the magnitudes of the forces that must be applied in order for the math to work out. This also means that the second law can be rephrased to state that the acceleration an object experiences will be directly proportional to the force applied and inversely proportional to its mass.
just want to note that Professor Dave did some calculations here. A feather to go 1 meter per second squared takes 1/10, 1/100th, 1/1000th, 1/10,000th, 1/100,000th of a Newton to get it to move fast. A tennis ball takes 100th of a Newton, 500th of a Newton, 10th, 100th, 500th of a Newton. But a barbell set, now this makes perfect sense, 25 Newtons to get that to go 1 meter per second. So it's going to take, the heavier it is, more massive it is, to get it to accelerate, it's going to be harder to do, right? So that's why they say it's proportional. So as we want to, the amount of force we need to use to get it to go fast increases as the mass increases. So it makes sense. So make something heavy takes more force to get it to go. Make something light takes less force. So they're going in the same direction, right? The mass is going up, the force has to go up. The mass goes down, the force goes down. That's what they mean by proportional. So let's take a look at this question here. So the last two questions in this particular section. All right. Here we go. Thanks for participating, everybody. Thanks so much. All right. The heavier an object requires a blank force to achieve the same acceleration as lighter objects. Is it greater or smaller? It's not equal or opposite. It's greater or smaller. Greater or smaller. So we got 6 people, 7 people. We got 10 the last 11 the last time. 9 people. That's it. Lost somebody. They walked away, published the poll, and 8 of you got it right. It is the greater force. Okay, heavier means greater in order to accelerate. Think about when you're playing, then people are playing football, right? If you're trying to move somebody that's heavier than you, it's pretty tough to do. It takes a lot of force. You could be small, but you're going to have to hit that person really hard. All right, so greater. All right, so what we said, this last one, acceleration of the object is directly proportional. That means as we increase the what, the blank for applied something, what's happening to the acceleration? Do we increase the force or do we increase the mass? Okay. It's either force or mass in this particular case. Some people put density and not too many, right? We got 7. Okay. So we're trying to give this idea out for you. Okay. So we got 9 people again, and it looks like 5 people said it is the force, as the acceleration of the object is directly proportional to the force. So increase the acceleration, we need more force. That makes sense, doesn't it? Okay, so what we're going to do today, all right, so there's an exit quiz at the end of the hour, 3 questions. We're going to do 3 questions. Hi, Luna. Okay, Luna, we want to pay attention to what we're doing here rather than talking to other people, okay? Thank you. Guys, I'm only given like 30 minutes, and I've got less than 30 minutes to get these things done. So please pay attention to this. I appreciate you, and then we'll have that wheel of science. Okay, so here we go. All right, so I'm going to clear these out. Okay, so let's do some questions here. All right, so this one, we can do this one together. All right, and this one is mass times acceleration. Get your calculators out, ladies and gentlemen. This is something that's pretty straightforward. Okay, so let's do this. Pretty straightforward. All right, so here we go. Force. So our force is equal to the 20 kilograms times 2 meters per second squared. You will get the answer. Oops, wrong way. The answer in newtons. All right, so what do you got? All right, we got one person. Kylie, thank you. Natalia. Jaina, I got your answer. What's 2 times 20? 20 times 2. 20 times 2, not divide by 2, 20 times 2. What's 20 times 2? What do we got? All right. Okay, so all right, so you can't hear me, Jana, because you need to refresh. Okay, so the polling, most of you got eight people that said 40. That's correct. I'm not sure how people got 10, unless they divided, or 15. I'm not sure how they got that either. Oh, can't tell you why it's not working. So go out and join again. Let me just try to give Jana some question here. Rejoin. Okay. All right, so let's try another problem here. Okay, now this is the toughest one you're going to have to do. All right, so this one is one where you're going to, so follow along with me on this one. Okay, this is exactly similar to one in the quiz today, or a quiz this week. So it says, what's the force needed to require to cause a 10 kilogram object to cause the acceleration from 2 to 3 seconds? So we're looking at this right here. All right, so we're looking at this area right here, 2 to 3 seconds. And we have to go back to what we did with acceleration, which was velocity final minus velocity initial divided by the time. So we've got velocity final is 40, right, minus 20. Okay, so this is, and we're dividing by 1, so this is 20 meters per second. Right, now we have our 10 kilograms times 20 equals newtons. All right, who knows how to do this one? All right, so okay, so 10 times 20. So I had to get this acceleration here to find the slope of this line. I had to take the final one, which was 40, minus 20. This is the toughest one. All right, Luna. Thanks, Harley. Thanks, Leiden. I know. Come on, guys. You can do this. 10 times 20. What is 10 times 20? All right. You guys got it. 8 of you got something there. All right. So we're going to get 8 people said, most people said 200 newtons. Okay. Last one in here, and then we're done. Okay. All right, let's do this one here. This one is the one we have one more question here. This is acceleration. So remember, when we do acceleration, if we use that triangle, it says force divided by mass. Okay, so this is going to be 15 newtons divided by 0.5. Okay, so let's see if you guys got this poll here. Let me start a poll. What is 15 newtons divided by 0.5? So remember, it's got to be, you have to hit the 15 first, hit the division symbol, and then put the 0.5, and then you're going to have this in meters per second squared. Okay, so go ahead, tell me what you got here. What is it? Start the poll. What's 15 divided by 0.05? Nope, not 15. It's not that. 15 divided by 0.5. There we go. Right, and it's meters per second squared, so meters per second squared. So acceleration is always meters per second squared. All right, got lots of you guys. Nope, somebody put a 20 in there. I don't know why you got 20, but you got to take 15 divided by 0.5. Maybe it's my writing. 15 could be very well 15 divided by 0.5. All right, so publish the poll. Okay, most of you guys got 30 meters per second squared, which is perfect, exactly what you want. Okay, so what I'm going to do, I'm going to take a few minutes and recap here with people. So